folks, it's me Tabo and welcome to another episode of Coding for Superheroes. So today we're going to be creating this creature over here, okay? So in this lesson, I'm going to be teaching you how to create curves. We're also going to be using curves to create a tube mesh, because that's what I used to create these tentacles, or whatever you want to call them. And we're also going to be using instance meshes. I think this is the first time that I'll be using instance meshes in my lessons. Might be wrong, don't really remember, but I think it's the first time. And this will also be the first time that I use a mesh physical material. But the setup will be basic. There will really be nothing complicated about it, no different to other materials that I've used before. So yeah, let's just jump right in. Okay. So as you can see here, we've got our boilerplate. So let me just make sure that everything is visible. Okay, I will just scroll every now and then for the parts that are a bit hidden. So as usual, yes, I've got a renderer, camera. I've set the scene to this color. It's a dark gray color. And another thing, the camera is set to position 10 for the Y and the Z axis. So you can do that also, but the rest is just pretty standard. Okay, so this is where we're going to start. I'm going to start by creating two lights. One light is a point light and another one is an ambient light. This is the intensity setting for our point light, and this is the intensity setting for our ambient light. Next, I will create a dodecahedron geometry and then create a material, a mesh standard material. I will just set it to red, the color that is. And then after that, we'll create a mesh out of it using the geometry and the material. After that, I will set the matrix auto update to false because I don't want it to update automatically. We will do that in the render function. Okay, next I will create two variables, normals and position, and these will be assigned the normal attributes of our dodecahedron, and this one will be assigned the position attributes of our dodecahedron. And then next we'll create three arrays, one called line points, one called tubes, and one called curves. Next we'll create a for loop. Okay, so we'll set it to 5 over here, and then we're gonna create points, and then we're gonna push them into this line points array. Next, we will create a curve. This is a cat-more-rom curve 3, and then we're gonna use this line points array. This is basically for the points, to create the points for the curve. And then we'll create another variable called curve point, and this will get the points. You can always increase the number of points that you want. Basically, from the curve that you've created, you can also still kind of add more points by putting a number. For instance, if I say 100, then you'll have like 100 points running across, but it doesn't influence the shape or the size of it. Okay, next we will create a tube geometry. So we will be using the curve. Well, this is what will create pretty much the different points. So now if we go to the Threejs website just to look at what a tube geometry class looks like, this is what it looks like. So in order to create it, you basically need these parameters over here. So like I showed you, this is the curve, and then this will be the tubular segments, radius, and then radial segments. So that is pretty much what we have, and then that will be false. This is whether or not you want the tube to be closed or open. So we will set to false. So after that, we will create a mesh physical material. We'll make the roughness 0, transmission 1, transparent true, thickness will be 5, and then opacity will be 0.8. Then after that, we'll create an instance mesh out of those, and then we're going to use the normals count, which is this over here. Okay, and then after that, we're going to set the draw usage to 3 dynamic draw usage, because we're going to be making some changes to it as we go along. Okay, next we're going to create 3 variables. 2 of them are going to be vector3 object, and then this one dummy obj, this will be object 3D. We're going to use this to basically change the matrix of our mesh. Okay, next we create a function called tube animation. So what we're gonna do here is we're gonna iterate through the normals. Basically, we're gonna get like the vector3 values for the normals, and then this is the index. Okay, so this is the index for the value that we're gonna be assigning to normal parts. Same here for vertex pos. This is just the values for the vertex positions. Then after that, we're gonna add the vertex position to our normal pos. So what we're doing is we're getting the direction of the normals and also the position of the vertices. So now we're gonna be placing each tube mesh on the vertice position and facing in the direction of our normal for that vertex. And then after that, we're gonna take the position of the vertex position onto our dummy OBJ, and we're gonna use the normal direction as our lookat. Then over here, we're just gonna update our matrix and our matrix world, and then we're gonna set the matrix using our dummy OBJ. And then after that, we're gonna parent them to our dodecahedron mesh, because we're gonna be rotating basically the whole thing. So the best way to do it is to actually parent the tube meshes to the ball, to the dodecahedron. And then after that, we're gonna then update the instance matrix. Okay, so now that that is done, we're just gonna call it over here. We'll call the function. Next, we are gonna create another function. It's gonna be called dodeca update. So this is where the rotation is gonna be happening. Okay, so we're gonna rotate it, and then we're gonna then update the matrix. So this function will be called in our render function. Over here, we're gonna add our dodecahedron to our scene, and then we're gonna add both lights as well. And just remember to also do this, the position Y and Z, make it 10, and then our camera lookat will be looking at our point of origin of our scene, which is scene.position. Okay, and so just over here, I'm just gonna create a variable which I'm gonna be using for as our time. Okay, this is just an option. You can use the 3.clock, use the elapsed time if you want to, but this also works. So inside of our render function, we're gonna then increment this by 0.03. And then we're going to call our dodeca update, and then we're going to use the time. So the dodeca update, the function that we just created, this will just be rotating the dodecahedron. And then inside of the render function, I will create a variable called offset, and I will make the value to 0. So this offset will be used inside of our for loop. So we're going to be looping through the curve points. Right, and then we're gonna be animating the curve points this way. So we're gonna be using once again our math function. So basically this is rotating them like it's just moving in a circular motion, you know. And so we'll be using the offset to make the rotation interesting, because without the offset, then it you don't get the waves. So that's what the offset does. It basically creates the waves. So each and every point is moving at a different pace, which then ultimately creates the wave. And then we'll then increment the offset by 0.9. So over here, we're gonna dispose of our geometry because of the changes that we're making. So in this case, we have to recreate the geometry so that we can keep updating the value of the curve over here. And so over here, then we're gonna then update our instance matrix for the tube mesh. And that's pretty much it. So let's have a look at what everything looks like. So once again, I'm just gonna run my server. Okay, so it's at local 8081. Okay, so this is what it looks like. So yeah, looks like everything is working out, and as you can see, it's very performant, you know. I think you can probably have a few of these running around, you know, or flying around or floating around, whatever. But yeah, one thing that I also want to mention is that as I was doing this, I noticed there was some inconsistencies because I'm using two different folders, and I think the one I'm creating this tutorial from, the Threejs master folder, was a bit old. So if it turns out that it looks different because the tentacles were gray, as you can see here, they're a bit dark, almost like black. In the previous versions of Threejs, for whatever reason, it's gray. So I'm not quite sure what changes they did to the material, but this is like kind of probably the default. So if that happens, just you can update it, because when you change the color, then it just kind of complicates it, because then you have to find the right light settings and whatnot. But overall, this is it. Once again, I just want to say, if you've gone to this part of the tutorial, then be sure to like, subscribe, hit the notification bell so that you can get more goodies from me. But without saying too much love and peace, I'm out.